Cool. Hi, my name is Jia. I got my PhD here exactly under Ian Foster and Dan Katz. So don't blame me for my bad taste for coloring. I'm not good at it. So this is a NSF funded CSSI framework project we just started this year. So we're going to build a new GPU cluster interface for domain scientists for them to train large foundational models, and it's called Diamond. Okay, so this is a collaborative project with now I'm with Rutgers, with Kyle and Ian at UChicago, and Vlad from NCSA UIUC, and Shivaram from University of Wisconsin-Madison, and my previous colleague Ying-Zhi Wang from TAC. So think about the interface we're using today to train large foundational model are, on GPU clusters or supercomputers, right? We have Aurora, we have Polaris, and Perlmutter, right? So most of the time, I use a terminal and use command line to deploy data, deploy model, and train it on, many GPUs for days or weeks. Right? So, they certainly provide some interface. Most of the centers provide support for Jupyter Notebook. You can program with Jupyter Notebook, right? But it doesn't let you run a model through Jupyter Notebook on many GPUs. And another thing that the user is really unaware is there is a performance profile, scaling profile for a certain application. The left-hand side shows the scaling curve of the OpenFOLD application, scaling from 16 to 128 A100 GPUs. The scaling efficiency goes from 100%, goes down to 67%. But users have no idea about this. And the second figure on the right-hand side shows a GPT-NeoX, actually it's a 6.7 billion model deploying on 32 GPUs, right? So the model itself requires 2 GPU to host a single copy. And with 32 GPUs, there are multiple legitimate deployment placement for the same model, but they give you different performance. And you can see if you maximize the data parallelism and minimize the pipeline parallelism, that gives the best performance. But again, users have no idea about this. So given the existing GPU user interface, what we can do is very limited, right? And it's a huge pain for domain scientists, especially when I support this type of work at Texas Advanced Computing Center. I got I don't know, maybe 10 or 20 users asking me every year about, how to do this. So we summarize those painful points into 3 categories. When they are developing and debugging the program, the neural network, right? And the second is about software configuration. How can I install PyTorch with this particular version and CUDA version on this particular machine, right? And once they have that running neural network, they want to scale it to multiple GPUs, right? So how to convert a single GPU code to multi-GPU? How do I apply my long-running job? For example, I train BERT. I have to run on 16 A100s for 5 days, but most of the centers will only allow you to run 48 hours. You have to plan several jobs. And when the machine is busy, you have to wait in the middle, right? So how do we plan jobs for long-running training? And how do we plan hyperparameter tuning? And how do we plan model placement for best performance? And for somebody like me who has access to several supercomputers, how do we do cross-cluster training? Taking opportunities wherever that is available. And how do we manage the data across those clusters? And also for the dissemination phase, how do we publish the model and how do we manage provenance, right? So based on this need, we propose the Diamond project. So it's supposed to be a new interface that is enriched by HPC and deep learning knowledge to the existing interface. And conceptually, I'm just drawing this up, as a conceptual display. It doesn't exist. So, we use globus authentication or maybe some other authentication methods for users to log in. And once he or she logs in, he will see 3-tab web browser, a web browser with 3 tabs. And one is for VS Code or Jupyter Notebook, where he can log in on a machine, land on there and start programming, right? And we also provide a container configuration interface where the user can start with a base container image and configure what exactly package they need. And also we can take a requirements file that build this container image for him or her, and then we can place this image on the platform that he or she has access to. Then we'll have this control panel where the user supply a command line in a Slurm script. So then we can break long-running job into smaller pieces and let Daemon to manage those smaller jobs, and provide functionality on different machines. This is supposed to be a drop-down list, but I don't know how to visualize it. Okay, yeah. So technically, it's more complicated than you think. For each of these functions, it has a connection to a particular software, that provides this function. For example, the develop user interface, once we were thinking about Open on Demand, and we're now also considering VS Code for container configuration service, and we build it for ourselves. And for function, for actual training job, we will leverage FuncX, which is Globus compute, right? So it's easier for us to leverage this function, and since FuncX already runs on several large-scale supercomputers, so we'll just take advantage of that. And also for autoscaler, you probably didn't see, I use a color scheme for each university to indicate the assignment of this research task. Yeah, but this is how it looks like. And I can take some questions.
When does it go
live? That's also a good question for NSF. I hope we will have a prototype running with a very basic functionality in 6 months. Yeah, so without advanced functionalities, but let user log in, program debugging, and run simple jobs on for the debugging purpose, right? And also for simple running. But for advanced job placement, optimal scale selection, we'll have to wait. It's a 3-year project, so.
If you go, your last slide is very, so philosophical question. This big picture project management. How do users make choices? Right? So this is the hard one, right? Do they say, okay, I know I want to use the workflow technology Parcel, and then I go look for, or do I start with the facility and then go back? And I guess I'm not asking so much how does your system work, but rather how do you think about how users approach the process of deploying?
So I think from my experience supporting those users, I believe if we can have several base images that provide very basic functionality, like we run PyTorch 1.13.1 with this CUDA version, that will satisfy maybe 60–50% of the requirements from the users. And for users who are experienced from that point, they require particular package or particular version that has long dependency, then we can use this container builder to help them to build their own container. So the approach is address 80% of the needs with some commonly identified package combination. And for the other 20, we'll let user to manage themselves.
So you're giving them lots of choices.
Yes. Well, in the beginning, not.
Let's talk more over coffee.
Depending. Yeah.
Okay. Any other questions? Anything on Zoom? No. Okay.